We'll now start our scheduling type problems, example 1. In scheduling type problems, what we have control over always is the number of workers to schedule during each shift. Our constraints are always time period based. So there's time periods, so the day that we need so many workers, and we have control over how many workers to schedule over each shift. Here's our partial Excel spreadsheet. I'm just going to start off with my decision variables. I can decide how many officers to schedule for the following 8-hour shifts. The problem says they work 8 hours, so first I'm going to write into my Excel spreadsheet all the possible 8-hour shifts. So an officer could start at midnight and work till 8 a.m. That's 8 hours. Or he could start at 4 a.m., work till noon, 8 a.m. to 4 p.m., noon to 8 p.m., 4 p.m. to midnight, and 8 p.m. to 4 a.m. So these 8-hour shifts are given to us in the problem, and these 4-hour periods are constraints. There's obviously some overlap between these 8-hour shifts and the 4-hour periods. So to capture this overlap, we're going to create what's called a time grid, and this is going to be in every scheduling problem. This time grid will show the number of officers working the following 4-hour periods who work the following shifts. So I'm just going to put a made-up number here. Let's say I schedule 2 officers from midnight to 8 a.m. So those officers working from midnight to 8 a.m. cover these 2 4-hour periods. So equal to B10 equal to B10. And then they're off work at 8 a.m. and they don't cover the rest of these periods. I'm going to put some more numbers in just to help us out. Just for example, so these 3 officers working 4 a.m. to noon, they will cover the periods 4 a.m. to 8 a.m., B11, and also 8 a.m. to noon. But then they're off work, so they don't cover any of the other periods. Next shift, 8 a.m. to 4 p.m., there's 4 officers working, so those 8 a.m. to 4 p.m. officers will cover the 8 a.m. to noon, and noon to 4 p.m. periods, and so forth. So you kind of get the pattern. Noon to 8 p.m. starts here. They're off work, 4 p.m. to midnight. And then the last 8 p.m. to 4 a.m. will cover 8 p.m. to midnight. And then it's going to wrap around here. We'll also cover the midnight to 4 a.m. So we've completed our time grid. Now we want to total up the actual number of officers working each 4-hour period. I'll find that by summing down each 4-hour period. The actual number of officers working each 4-hour period must be greater than or equal to the minimum required, which is found in our constraint time period above B6. We need at least 8 officers from midnight to 4 a.m. Clearly, we don't meet that with our current schedule. This is true for each 4-hour period. I'm going to drag this across. It's just copying the data up there. Our objective given in the problem is to minimize the number of officers scheduled. So let's create a cell for total officers working, which is simply equal to the sum of my decision variables. And we want to minimize that. Let's go ahead and solve it. Okay, we have a solution. We have now a schedule to follow to minimize the total number of officers working and ensure that all constraints are satisfied.